Good morning or afternoon. Today we're going to talk about how you prove that lines are parallel. So if you think back to what we did the other day we talked about how if the lines were parallel, then all of these things were true. Then the corresponding angles were congruent. Alternate interior angles were congruent. How we prove that lines are parallel is by flipping those, is by saying if the corresponding angles are congruent, well then the lines are parallel. So the key thing about today is that we're doing what we did the other day, but now we're flipping it. So ask yourself, is there a word that means flip whenever we flip those if-then parts? And if you thought of converse, you're right. So today we're talking about how we prove lines parallel, and it's all through using the converse. It's all by using the converse. So the way that works is now you check to see, we can't just look at the picture, now you check to see, are your corresponding angles congruent? Because if the corresponding angles are congruent, well then your lines are parallel. It's the flip of what we did the other day. You check to see, are the alternate interior angles congruent? And if they are, then your lines are parallel. Asking yourself, what should alternate exterior angles be? Hopefully you said congruent, because if they're congruent, then your lines are parallel. And with same side interior, same side exterior, remember that SS meant that these ones should be supplementary. And if they are, then your lines are parallel. So that's how we complete these geometry proofs, is we just check to see what type of angles we have. Are they congruent or supplementary? Which one are they supposed to be? And if that's the case, if that's true, well then the lines are parallel. And what's nice about these proofs is that there's no solving, there's none of that. We're really just checking to see, are they congruent, are they supplementary, what are they? And then we go from there. So it says, state the postulator theorem that you would use to prove that the lines are parallel if they are. So we're checking to see what type of angles are 58 and 122. Well, they're same side interior, which means that they should add up to 180. So check, what's 58 plus 122? Well, they do add up to 180, which means, yeah, P is, watch how I write it out, P is parallel / / I'm going to use that symbol. P is parallel to Q. And if I asked you why, you would say by the same side interior converse. Now, you have to put that word converse there because we're not solving, we're not doing any of that. Now we're checking for the angles. We're going backwards. So now we checked, were the same side interior angles supplementary? Yes. So then the lines are parallel. We flipped it, so it's called converse. Okay, taking a look at the next one. I know this is 120. It should go with that one right there. Ask yourself, what type of angles are in that spot? Top right, top right. Okay, that would be corresponding. And they don't tell me, they tell me 82 and 40. Well, 82 plus 40 would make that 122. So I have 122 and 120. We'll go back. Corresponding angles should be congruent, but they're not, which means that the lines are not parallel. The corresponding angles are not congruent. I'm just reading. The corresponding angles were not congruent, then the lines are not parallel. That's that inverse. So I'm going to put no, they're not parallel. So let's take a look at our next one. So I have one top right, top left, one's interior, one's exterior. Okay, but I do know, remember that if this is 88 vertical angles, tell me if this is 88, then this one right here also has to be 88. That has nothing to do with if they're parallel, nothing. That's just a vertical angles all the time. Okay, now I can compare these ones. So asking yourself, what type of angles are those? Well, those would be same side exterior, which means same side exterior, they should add up to 180. So go ahead and check it. What's 92 plus 88? Well, they do add up to 180, which means that L is parallel to K, and my reason would be by the same side exterior converse. The same side exterior angles were supplementary. Yep. So then the lines are parallel. So let's take a look at this last one. Okay, I know vertical angles are congruent. Great. They give me no markings up there. So they don't give me anything to relate this line to this line, nothing to relate these angles to these angles, which means on this one, I have no idea. We don't have enough information, so that's just what I'm going to put, not enough info. Maybe they're parallel, maybe not, but we don't know anything on L to relate L to K, so not enough info. Now, that's how we prove that lines are parallel, but a lot of times it's not going to be in this format. It's going to be in a 2-column proof. Now, if you remember, 2-column proofs are just literally set up 2 columns with statements on the left and reasons on the right. And it's going to give you some information, and it's also going to tell you what it wants you to do. So the way that proofs always start is with the given. It doesn't matter the proof. They're always going to start with the given. So this gives me this information. Angle 4 is congruent to angle 6. So that's how I'm going to write it. Angle 4 is congruent to angle 6. That's my statement. What's the reason? Well, they gave it to me. It was given to me. But they want me to prove that the lines are parallel. So now I'm going to go look at my picture and ask ourselves, do we know anything about angles 4 and 6? Are they any relationship? Is there anything special about angles 4 and 6? And when I say is there anything special, I'm looking for, are they one of these? Are they corresponding? Alternate interior, alternate exterior, same side interior, same side exterior. Well, they're alternate interior. They're supposed to be congruent, which they are. And because those alternate interior angles are congruent, it means that the lines are parallel. So L is parallel to M. And you can do that / vertical if you want to. Okay, well, what's your reason? It goes back to what type of angles were they? Well, they were alternate interior angles, which were supposed to be congruent, which they are. So I'm going to say alternate interior, but I need that word converse. Okay, now I only need this word converse whenever we're proving that the lines are parallel. So make a little note. I only need the word converse is needed when proving lines are parallel. So notice it wanted us to prove that the lines are parallel. I need the word converse in my proof. So taking a look at this next one, it tells us that the lines are parallel, and it wants us to prove that angle 1 and angle 6 add up to 180. Okay, proofs always start with the given. Before I really even use my brain or any of that, I'm just going to set up a 2-column chart. And I'm going to go ahead and write it out. So line M is parallel to line N. So I can just write M parallel to N because it's given. Okay, so M is parallel to N, which means angle 1 would be congruent to angle 5. Those are corresponding. Angle 3 and angle 6 would add up to 180 because those are same side interior. And my goal is it wants me to talk about angle 1 and 6. Okay, well, 1 and 6 aren't anything special, but I did just say that 3 and 6 add up to 180. So ask yourself, why do 3 and 6 add up to 180? What type of angles are those? And if you said same side interior, right. So that's what I'm going to write first. I'm going to say, well, I know that angle 3 and angle 6 add up to 180. 1 and 6 aren't anything special. That's not anything. But 3 and 6 I know add up to 180 because they're same side interior. That's my reason. I don't need that word converse. I'm not proving that lines are parallel. Okay, well, I know that 3 and 6 add up to 180, but it wants me to say 1 and 6 add up to 180. So now I'm going to see, well, do I know anything about 1 and 3? Can I relate 1 and 3? Ask yourself, what type of angles are 1 and 3? Well, 1 and 3 are vertical angles, so I'm going to go ahead and say that. I'm going to say that angle 1 is congruent to angle 3, or angle 1 is equal to angle 3, because those are vertical angles. Okay, but remember, I didn't want to say 3 and 6. I wanted to say 1 and 6. So ask yourself, was there a property that allows me to just swap something out? Does it allow me to just swap a 3 for a 1 because those are exactly the same? And there is. Substitution property allows you to just swap those out. So now I've said that they're supplementary by substitution property. Now, proofs can sometimes be a little bit confusing. It might seem like I explained that kind of fast. If that's the case, I'm going to say go back, rewind, rewatch. But just be aware that you won't have to do these proofs completely from scratch. You do need to know how to do some proofs, but you're going to have some guidance on these proofs. And some are going to be a lot longer than others, and that's okay. Just know that you won't be entirely on your own for proofs. You'll have some guidance. You'll have some steps to kind of go there. So let's take a look at another one. It says, given that the lines are parallel, prove that the angles are congruent. So before I even start thinking, really using my brain, I'm just going to go ahead and set up my chart and copy down my given. So M is parallel to N. My statement always goes on the left, and given will always be in the top right. And I always have students ask, will given always go there? Yes, every single time. Given will always go on the top right, always, every single time. Okay, so M is parallel to N. They want you to prove that angle 1 is congruent to angle 2. So ask yourself, is there anything special about angle 1 and angle 2? Is there anything we know about those angles? Well, if you said that they're alternate interior, then you are right. They are alternate interior. And remember that alternate interior angles are supposed to be congruent, which they are. So I'm going to say, yeah, angle 1 is congruent to angle 2 because the lines were parallel and those were alternate interior angles, and alternate interior angles are congruent. And for this proof, that just happened to be all that I needed. Notice I didn't even need the word converse because I wasn't proving that the lines were parallel. They told me that in the first step in that given. So let's do another one. Now I have that L is parallel to K, and now it says that angle 1 and angle 2 are supplementary. That's what I'm trying to prove. That's my end goal. So I'm going to go ahead and set up my chart. I can just copy down that given. L is parallel to K because it's given to me. And now I'm going to look at my picture and think, is there anything I know about angle 1 and angle 2? Is there any special relationship? Is there anything special about angle 1 and angle 2? Were they one of those 5 from our chart? Are they corresponding? Alternate interior, alternate exterior, same side interior, same side exterior? Well, those are same side interior, and those angles are supposed to be supplementary. So, yeah, I can say that angle 1 and angle 2 are supplementary. What's my reason? Because they were same side interior, and those angles are supposed to be supplementary. So I want you to take a look at these 2 proofs down here and ask yourself, is there one where you would need the word converse? We talked a little bit ago about when do you need the word converse. If you look at these proofs, they're pretty much exactly the same. Which one would you need the word converse in? And if you said the one on the right, you're correct because we're proving that the lines are parallel. But let's go ahead and start with this other one. So it says, given that M is parallel to N. So I'm going to set up my chart. I'm going to go ahead and write out that given. Okay, I'm going to see, is there anything special that I know about angle 3 and angle 2? Is there any type of relationship there? Are they corresponding? Go through your list. Are they corresponding? Are they alternate interior? Are they alternate exterior? Are they same side interior, or are they same side exterior? And if you got alternate exterior, you're right. They are alternate exterior, and alternate exterior angles are supposed to be congruent, which it says that they are. So here's my proof. Yeah, angle 2 is congruent to angle 3 because they're alternate exterior. And that's the extent of my proof. I'm done with it. Just those 2 lines done. I want you to pause and see if you could do this last one on your own. I'll give you a hint and tell you that it should only be 2 lines. You should only have 2 lines in this proof. Okay, hopefully you paused and were able to get this done. Our given is that angle 2 is congruent to angle 3 given. Okay, just a second ago we said that angle 2 and angle 3 were exterior angles, alternate exterior and alternate exterior angles. If they are congruent, then your lines are parallel. Well, they're alternate exterior, they are congruent, which would mean that our lines are parallel. So I'm going to say that M is parallel to N. Why? Alternate exterior angles. But because I'm proving that the lines are parallel, I just have to write in that word converse. And that's it. That's how we prove that lines are parallel. Be sure to be checking this list, making sure that you know these vocabulary words, making sure that you know which one is what. And that's going to be a